Sir Isaac Newton was an English mathematician, physicist, astronomer, alchemist, theologian, and author widely recognized as one of the greatest mathematicians and physicists of all times, and most influential scientists. He was a key figure in the philosophical revolution known as the Enlightenment. His book Philosophic Naturalis Principia Mathematicae, or also known as Mathematical Principles of Natural Philosophy, first published in 1687, established classical mechanics. In Principia, Newton formulated the laws of motion and universal gravitation that formed the dominant scientific viewpoint until it was superseded by the theory of relatability. Newton used his mathematical description of gravity to derive Kepler's law of planetary motion, account for tides, the trajectories of comets, and the precession of the equinoxes and other phenomena, eradicating doubt about the solar system's heliocentricity. He demonstrated that the motion of objects on Earth and celestial bodies could be accounted for by the same principles. Newton's inference that the Earth is an oblate spheroid was later confirmed by the geodetic measurements of Maupertuis, Lacondinate, and others, convincing most European scientists of the superiority of Newtonian mechanics over earlier systems. Three laws of motion: law of inertia, law of acceleration, and law of interaction. Newton developed his law of motion in 1666 when he was only 22 years old. He presented the laws in his seminal work Principia Mathematica Philosophia Naturalis, in which he explained how outside forces affect the movements of an object. In developing his three laws, Newton simplified objects, reducing them to mathematical points without size irradiation to let him ignore factors such as friction, air resistance, temperature, and material properties, and focus on the outcomes that can be illustrated fully with reference to mass, length, and time.
Yeah!
Law of inertia: an object at rest remains at rest and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. Stirring coffee. After you swirl a glass of coffee, the coffee does not stop swirling immediately. It continues swirling for some time, after which it stops. This is due to the inertia of the motion of the molecules. Law of acceleration. A second law defines if force equals to change in momentum or change in time. Momentum is defined to be the mass of an object times its velocity. Hitting a ball. A ball develops a certain amount of acceleration after being hit. The acceleration with which the ball moves is directly proportional to the force applied to it. This means that the harder you hit the ball, the faster it will move, thereby demonstrating Newton's second law of motion in daily life. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. His third law states that for every action in nature, there is an equal and opposite reaction. If object A exerts a force on object B also exerts an equal and opposite force on an object. Resting against a wall. When we rest against a wall, we get a reaction force from the wall. You can understand this example by imagining if someone is to rest on you, then you have to apply some force to support the other person. This example of Newton's third law is also an example of balance force. Bouncing a ball. A ball is able to bounce because of the reaction from the ground. If there was no reaction, then the ball would not bounce but rather stick to the ground.